Hi, welcome to Algebra 2, Lesson 2-3, Example 5, Determining Positive or Negative Intervals. In Example 5, we're going to look at positive and negative intervals. So, we're going to identify intervals on which the function y equals x squared minus 2x minus 3 is positive, for example. So the y values of quadratic function can only turn from positive to negative or from negative to positive because y, when the graph crosses the x-axis, because by definition, your function is positive where? Your function is positive when your graph is above your x-axis. That means when your function, the value of your range is positive. So all the values that are greater than 0, 0 is not negative nor positive, right? 0 is just 0. It's not negative number, it's not a positive number, so greater than 0 would be positive, and less than 0 would be negative. So just by looking at this graph, you'll see that everything above this x-axis, which is when x is less than this point, -1, and x greater than 3 would be positive. And everything between -1 and 3 would be negative. Okay, so we're gonna describe the function using the intervals for the x values, but we are describing when the function, which means the y values, are positive or negative. Okay, so some people find it a little bit confusing because we're using both variables, but we're looking at where the y values are positive or negative, but we're describing it using the x values. Does that make sense? Yeah. Okay, so first of all, we want to factor this out to find the zeros of the function. We already have done that in the previous example, so you should know how to do it by now, right? X squared minus 2x minus 3 is equal to 0, so that we can find the zeros of the function, factor them out, use the zero product property to solve for x, and 3 and -1 would be our zeros. So in our graph, we see 3 and -1. That should be right. And then after you find the 0, without even getting to the graph yet, right? Because right now we only have the function and we just figured out the zeros. And after you figure out the zeros from the function you're given, you want to figure out if your values are positive or negative between those. Okay, we don't know if the two x-intercepts are going to which way it's going yet, right? We just know the x-intercepts, right? So it could either look like this or it could either look like that, right? Your quadratic function could either change from positive to negative and then negative to positive, or negative to positive and positive to negative here through the x intercepts, right, through your zeros. So you want to figure out any number below, that's below -1, to see if this part of your graph is negative or positive, right? So you can just choose any number. Here we chose -3, but you can literally choose any number that's less than -1. And then plug it into your function. When x is -3, your y is 12. Oh, it's a positive number, right? So it's going to be positive, which means your graph is probably going to look like this. Sorry, that's not a good graph. So you're probably going to have a positive to negative, negative to positive. You can check, but these steps are not necessary when you know it's going to be a quadratic function and it starts from positive, then you know it's going to be negative here, and then you know there's a 0 here, so that means the graph is going to go up here afterwards, right? So it's going to be negative between -3 and 3, and it's going to be positive when x is less than 1 and x is greater than 3. Okay, so we are looking at these y values if they're positive or negative. But again, we're describing using the x values when we're describing when it's positive or when it's negative. Okay, so finally, you want to say when it's positive, when it's negative using the intervals. You can just use the inequalities for intervals, or you can use the interval notation, negative infinity to -1. And please don't include -1 because 0, at exactly -1, your y is equal to 0, and 0 is neither positive nor negative. And then we can say it's positive, the graph is positive when it's from negative infinity till -1, and also positive 3 till positive infinity. And then it's negative, the graph is negative when it's between -1 and 3. Okay, so it may be easier to write it in interval notation, but you can also say and explain it's positive when the graph is above the x-axis, or in the intervals x less than -1 and x greater than 3. Okay, so let's do number 5. Try it. Identify the intervals on which the function y equals x squared minus 4x minus 21 is negative. So you'll use the same steps, but try to figure it by yourself. Pause the video, figure it by yourself, and come check for answers. Okay, are you ready? First of all, you want to find the zeros, right? That's your first step. So try number 5, find the zeros. You're going to factor it out, make it 0, and it's equal to x squared minus 4x. This is, try it, number 5, okay? Minus 21. You're going to factor it out. Factors of 7 that may add up to -1 would probably be 7 and 3 maybe, right? X minus 7 and x plus 3 would be a perfect combination, right? -7 times 3 would be -21. If you add them up, it's -4. And then you solve for zeros. X is 7 or -3. And so you pick a number anywhere in the graph that's not 7 and -3 to see where it's going to be positive or negative. So I know visually you have to think, oh, -3 is here, 1, 2, 3, 4, 5, 6, 7 is here, and I don't know if the graph is going this way or that way. So I'm gonna pick 0. So that it's easier to calculate. When x is 0, it's going to be -21. So it's very below here. And so I know the graph is going to look like this, where it's going to be positive when it's less than -3 and greater than 7. And then it's going to be negative between -7 and 3. Okay, so we want to identify the intervals where the function is negative. So we just want this interval. Okay, if they want us to identify where it's positive and negative, then we would just write both. But in this problem, we just want to identify where it's negative. So you can either use inequality to say, oh, x is going to be between -3 and 7. Or you can use interval notation saying -3, 7, which means from -3 to 7, it'll be negative. All right, so we're going to continue with our last example in the next video. So stay tuned. Bye.